Hello, friends. Welcome to Akul Mac Live. And the exciting part is the James Webb Telescope is now completely inflated. As we say that it is inflated, that means all its components have been activated. They are completely in the position to start recording things. However, James Webb has not reached its final destination, so it's en route, and because of that, we will not start getting the inputs from James Webb Space Telescope. But let's go back to our main discussion point, which is the inflation. What has inflated? Basically, James Webb is a very, very large telescope. It was folded like an origami, and it has a large mirror also. So today we want to basically talk about what is so special in this mirror. As you can see, this mirror is huge, and it consists of hexagonal many parts. Many individual mirrors which are put together on certain mount, and then they are using computer angle at a particular point, so that more and more light can be gathered and analyzed. Now, as you can see, this looks golden in color instead of silver in color. Normally, when we have a mirror, we expect that to be silver because we expect that the silver color or the mirror finish gives out all reflections. In fact, it is the best source. However, in case of James Webb, they have chosen golden color. So, what is so special about it, and why it is so wonderful to, in fact, even analyze this aspect of James Webb? And as you know, James Webb has taken 30 years of making. They have used all the knowledge gathered in past 30 years to make this, and therefore this mirror is so special. First of all, this mirror is made of something called beryllium. Now, beryllium is a very light compound, and it is just number 4 on the periodic table. So it's very light. It is sort of a metal. It has a very high boiling point and also melting point, and it is quite rare. Actually, when we talk about the rarity of beryllium, it is so rare that of the total mass of the Earth, the beryllium found on Earth is only 0.0004%. Now you would ask why this is happening, because usually when the elements are lighter, they are abundant, especially if you look at hydrogen, helium, nitrogen, and so on. So these are the lighter elements, and they are found everywhere, and beryllium being one of the light element but not found. So the secret lies in the sun itself. When the star basically start making beryllium, it has a tendency to react very actively. And in fact, beryllium on Earth cannot stay without oxidizing itself. When I say oxidizing, it's basically react with oxygen. So therefore, beryllium is not freely available, and at the same time, since it is a very heavy nucleus, it has a tendency to convert into other heavier element. It reacts in the core of the star, which in our case is sun. It reacts with other elements and it becomes sort of a catalyst to form other heavier elements like carbon, etc. So that is why beryllium is very, very rare. And when we talk about the properties of beryllium, why it has been chosen to be part of the James Webb mirror, or basically the entire mirror is made of beryllium, because it is very, very lightweight. It is lighter than aluminum, and it is stronger than steel in the pure form. And that is why beryllium is a very good material to be used for spacecraft, and wherever in the machinery where you need a lot of strength but don't want to add weight. And telescope being one of the major equipment which requires these two properties. So beryllium, even though it is very rare on Earth, this has been used to create the mirror, the base of the mirror of James Webb. So moving forward, This is also called miracle metal because because of these properties. But since it is very reactive, it is very difficult to purify beryllium. And at this point in time, as we speak, only three countries are known producer of beryllium, which is US, China, and Kazakhstan, because of the mines found there. But as of now, Kazakhstan has run out of all the beryllium they had, so only US and China as we speak. And because of that, the base of the mirror which are used in James Webb is made of beryllium, even though it's a huge, it is like 10 times bigger than the other Hubble telescope, but it is very light, very strong, very sturdy, and it does not get affected by the temperature variation because it has a very high melting point, almost like 1200 degrees plus melting point. So it is very stable element, and therefore it has been used to make these hexagonal base of the mirror. Now, the second element which is used to make the mirror is gold. Instead of silver, the scientists have used gold, and very thin layer, almost molecular layer of gold is spread across evenly on beryllium surface. So first of all, the beryllium was created, these hexagons were created, and they were polished as if they were mirrors, and then on top of it the gold was coated on it. So why they have chosen gold? I think the property of gold, as we know, it's a inert metal. It does not react, and that is why its yellow luster never fades. It does not react with anything. So that is one of the property. But the bigger property which is used here is that gold is the best reflector for infrared spectrum of light. And since James Webb Telescope is an infrared observatory, so scientists wanted more infrared light than any other light so that they can observe the universe. That is why the gold is used as a reflector for James Webb Telescope. And together, using these two elements, which is beryllium and gold, James Webb has created this wonderful mirror which we see, and a huge mirror which is going to gather the infrared light, and then there is a spectrograph which will analyze all the frequencies of infrared which is received by James Webb. So the final product looks something like this. If I have to show you the final mirror, look at the size of it. I mean, if you just compare the size of the single hexagonal mirror, which is made of beryllium and a very fine coating, almost luster finish of gold, you can imagine, one single hexagon size is almost as big as the man which is standing next to it. So they have used so many, there are so many, and these mirrors are going to reflect the infrared light onto the analyzer of James Webb. So I think this is something that I thought I will bring to you as one of the key items, that a wonderful mirror has been created for James Webb. The scientists have used all their knowledge, they have used the best method and material, they have used the best mechanism to fold the mirror in such a way like an origami so that it can be unfolded when it reaches its final destination. So as far as NASA news is concerned, which is getting streamed live right now, the James Webb is completely inflated. It is now in the orbit, and it is going to reach the Lagrange point 2, which is also known as L2, within a couple of months. And once it reaches its final destination, scientists are going to switch on all its apparatus, and then it will start reading the universe in the infrared spectrum. Friends, I will end my program today. Do write your comments, and as you know, I respond to each one of your comments, and also read out some of these interesting comments in my Akul Mac Live shows. So I'll say goodbye today, only to catch you again in the next one.